Hello and welcome back. So to continue on with the Hare tutorial series, this video is going to cover the section on functions in depth. So go ahead and navigate to this part of the tutorial and let's go ahead and get started. So copy and paste this into your text editor. The functions we have written so far have a fixed arity. Functions taking one argument are unary, two arguments binary, three arguments trinary, and so on. Hare also supports functions with a variable arity. Such functions are called variadic. Now, arity, the term arity just means the number of arguments that can be passed to a function. So, a nullary function would take no arguments, a unary one, and so on. To declare a function as variadic, place this operator after the type of its final parameter. This will cause the type of the parameter to be a slice of this type. In the example, x becomes type int slice. Each additional parameter is passed to the function is appended to this slice. We can also call variadic functions in one of two ways, either by listing all of the parameters we want to pass directly, as in the first call to print ints, which is right here. So here we are listing them as literals, or by passing a slice with this operator, again, as in the second example. So that's right here. The FMT family of functions we've been using throughout this tutorial is also variadic, which is why we have been able to pass it an arbitrary number of arguments throughout the tutorial. Okay, so now let's go ahead and jump over into the text editor and see what's actually happening here. So when we define print ints to take a variable number of arguments, that's right here, okay? That's this parameter. And you can see the syntax for that. Now here is where we're calling it the first time, and from here, right, these literals are the ones that we're passing in, and each one gets appended to this slice of x. Here, we are actually creating a slice named x, and then passing in the entire slice to print ints, and it behaves in the same exact way. And here we're just iterating through, printing each value, and then we have an if expression that appends either a comma or a new line at the end of the slice. And so let's go ahead and run this. And you can see it prints everything just like we would expect. So this is just a slice, okay? When x comes into this function, so we could say, if we wanted to, let's take a slice of just the first two elements. Okay, so now a is a slice of a slice. It's a slice of the first two elements. So while I is less than the len of a, and then let's just print these two, and we'll say printing slice of slice, and then we will pass in our slice. So as you can see, I've taken a slice of the slice of x. And you can see each time we call it, we're slicing the first two elements of whatever slice comes in. So from the first call to print ints, it's 1 and 2. From the second call to print ints, it's 5 and 4. So you can see you can take a slice of a slice, and that's all this is. So this is just a slice. When this parameter gets passed in, it's just a slice to the function, and you can manipulate these values in any way that you can any other slice. So hopefully that's pretty straightforward. It's pretty simple. But if you have any questions, put them in the comments, let me know, and I will certainly try my best to help you. Okay, so now let's move on to the next example. Okay, optional function parameters. Optional function parameters can be used for functions which are usually called with one argument being the same. For the sake of this example, let's imagine we almost always want to print the age of Paula. However, occasionally we also want to print Tim's age. Instead of specifying Paula each time we call print age, we can include a default value for name after the assignment operator at its declaration. Note that optional parameters must always follow required parameters. So it's saying that your optional parameters have to be after um, required parameters. This is required, you have to pass this in, there's no default value. Notice the syntax here for declaring a function with a default parameter. Of course, this example is rather silly. However, a number of standard library functions make use of this. A notable example is OSOpen, which is declared like so. And we can open that in Hare and take a closer look at it. So here's the optional function parameter. Okay, so this is getting passed in by default, the read-only flag. Okay, same thing with the create function. You see this is a write-only and a truncation flag, and this will be creating the file, and this is it gets truncated if the file exists already. And so you see how this is defined, right? So you have the parameter, and then this is what it looks like here. So this is an optional parameter. We don't have to pass this in when we call this function. It's already being passed in by default. So you see this means that you can call OSOpen with only the file name as an argument, and the file will be opened as read-only. So that's right here. This is the path, which is of type string, str. This is a required argument. When you call this function, you have to pass this in. You don't have to pass in a optional functional parameter, or we could call it a default function parameter, because this is automatically passed in by default for us. Okay? Now this should be relatively straightforward. Let's go ahead and look at this though, and look at exactly what this is like. So here's the function here, and so here's the required parameter. Okay, and so when we call print age, we have to pass in an age. Okay, but here is the optional function parameter, and this is passed in by default. So when we first call print age with just the age, it's going to print the name of Paula, but we could, if we wanted to, pass in a name, and it will print the name as well. And here's what that's printing with the printf-line function. So let's go ahead and run this. And you can see Paula is 28 years old. This is passed in by default. Okay, Paula is the optional, or what we could call a default function parameter, and Tim is what we're passing in when we call this function. And again, two examples of that would be the OSOpen function and the OSCreate function. Both of these have optional function parameters. Many functions in the Hare standard library do. It's not just these. If you go through the modules and spend some time looking at the Hare standard library functions, you know, this is common in standard libraries to have default function arguments passed in when you call the function. Okay, so now let's go ahead and move on. Okay, for this next section, function pointers, go ahead and copy and paste this into your text editor. Much like other objects in Hare, it is possible to take the address of a function with the address of operator. You may then call this variable like you would any ordinary function. This allows you to choose between different behaviors at runtime. In this sample, we take the address of the add and sub functions and store it in a variable which has a function pointer type. And that would be this right here. That's what's happening right here. Here's the variable, here is the function type. Okay? Now what it's saying is the type is optional here. It could be inferred, but we chose to spell it out here to illustrate how these types are written. You can include these types in struct fields, function parameters, and so on, like you could with any other value. So what this basically does, what function pointers allow us to do in Hare, is it sort of mimics the behavior of like higher order functions, okay, or like even like anonymous functions almost. But you can, since you can assign a function pointer to a value and then pass this value around, it's saying just like you could with any other value. This basically, we could think of it in a way that it basically turns functions into higher order functions. Now, I don't think Hare supports proper higher order functions, right? Like maybe like Haskell does, but you can sort of mimic that behavior with this, right? In terms of just passing functions around as values, right? Again, you can embed these in struct fields. You can make this a function parameter, and I can show you an example of that. So let's step through this. Um, this is just defining a usage function, and this is going to be called if we don't enter 4 arguments from the command line. OSArgs, this is a string slice and it gets command line arguments. In order, you don't have to pass in anything to the main function. So, like you would C and C, right? You have in argc char star argv array or char star star argv, and that's how you get your command line arguments. You don't have to do that in Hare. You do that through this slice right here, OSArgs. And so it's printing usage, right, which is just this right here, returns type never, because it's we're calling fatal F. And so we're just printing the usage here and then the arguments. Or excuse me, the program name, because that's always the zeroth value of a function of command line arguments is the program name. So here are the 2 functions that we've defined, or that the program here is defined, and this is what we are actually assigning to this variable here. Okay, now we're using a switch expression on the first argument that we pass in. It's technically the second argument because again, the program name is the first pass in implicitly. So this is the first argument that we pass in. And we can say add if we want to add, or subtract if we want to subtract. And what that's doing, it's yielding this function pointer back to this variable, right? So this is just like saying func equals a function pointer to add. Again, this is all just type information of the declared type, right? We don't have to include this. It's spelling it out to show us how these types are written. And then we're switching on this because depending on what we pass in as the first argument to our program is going to depend on what function we're actually going to assign to func and call right here. So we see we're calling func right here just like any other function you see within the print line. But you call it just like any other function, okay? And as far as what's happening here, what we're doing is we're using strcom stoy, which is string to integer, and it's a string conversion module. It's a string conversion module. This is common, like if you program in C, right, there's a toy, ASCII to integer. This is string to integer. And what it's doing, it's converting the command line argument that we pass in to an integer. Okay, right here, it's yielding it back to x. Same thing with y. where are we at? Same thing with y. We are um, matching on this command line argument, and if it's a proper integer, it's going to return that to y, so that when we call func here, it passes in x and y, and these are now converted to integers, because when we pass them in as command line arguments, they're strings, okay? That's what, you see, this is a string slice. So when we, okay, so when we pass this in here, okay, when this gets passed in here, this first value, which is x, this is a string. We're using strcomstoid to convert it to an integer, okay? Now I have moved these functions to the top of the file just to kind of put them in view and kind of see what's happening. Now I also annotated something. If you notice, what's actually happening here with these functions, I guess we could call these inline functions. They're not inline functions in the very technical sense, right? Because an inline function is basically where the compiler performs optimization, and basically you can think of it like it pastes that code in where the function call is, instead of allocating a new stack frame, going into the function call, allocating variables. So that's technically what an inline function is, but we can kind of think of this syntactically, right, as sort of an inline function. And And notice that there is no return value here, okay, or excuse me, no return keyword. So when you define a function like this, it's returning this expression. It's returning whatever expression that you put in here, okay? So you can define simple little functions like this, quick little functions. Notice that usage is also defined this way, okay? Instead of, for example, what would be a way to define this actually? Let's say, and, and I'll just, right, and then you would have like this, and then you would actually have to return, right, whatever, x divided by y, okay? So notice that when we, um, notice that when we define a function this way, this is an automatic expression return, okay? Now again, let's step through this a little bit. Okay, here's the type, it's annotated. And what we're doing, here's what we're actually concerned with here, here's the variable, okay? And what we're doing is based on whatever we type in as the first parameter. If we type in add, it's going to assign a pointer to the add function to function. So what that looks like, it's basically like saying, okay, it's saying that right there. Okay, that's basically all this is saying. All this might be all this might be a little noisy, and I understand that. It's okay if it takes you a little bit of time to understand what's happening here, okay? Or say we pass in sub as the second argument. It's the same thing as just saying this right here. That's all this is doing. Again, this is just a type annotation. Okay, this is just a type annotation annotating the return type of the switch expression. Okay, and it's either, you see, a pointer to add or a pointer to subtract. So what it's saying here is that we don't technically need this. You could do just like this, and that's the same thing, okay? But it's annotating the type so that we can see exactly how these types are written. Now, if you notice, I don't know, this might have been a change from, say, like a previous version, like 25.2 to 26. In the tutorial, there are no types, or excuse me, these are not named parameters. But I'm on Hare version 26.0, and it requires that these be named parameters. You see, I'm just declaring this as x, this is Y, it wouldn't matter. Okay, you could name this A, you could name this B, and it wouldn't matter. You just have to name it something, but it does require named parameters. Okay, so that's what we're doing here, and then if we don't put in add or sub, we're calling the usage function. Okay. And here, again, we're just using strcomstoy to convert the first number that we put in to an integer. Same thing here with the other argument that we pass in. We're converting it from a string to an integer, and that's what strcomstoy is. Um, okay, so converts a string to an integer. And notice that, okay, this is a good point to notice this. This is also a default type, okay? So if we wanted to pass in something else, we could. So by default, it's passing in decimal, which is here, which is base 10. We could pass in this argument. We could turn this into a hex, okay, binary, an octal, okay. So this is a default argument, and it's converting it to a base 10 integer. Now, this is what the actual function call looks like, okay? When we're calling func, this is the variable. Again, remember, this is a variable that contains a function pointer, okay? But you call it just like a regular function. Okay, so let me run this, and let's come back in here, and I want to show you one other thing you could do. Now, what we want to do is we want to pass in whether we want to add or subtract. Okay, so let's say add, and let's add 7 and 7. And you see it gave us 14. Now let's try, let's say sub, and 21, and I don't know, 5. Okay, so that equals 16. Now let's say, let's call the usage function. So I'm not going to put in any other arguments, and what's going to happen is it's going to call usage and show us how to use this program. You see, so usage, main, and then add or sub, and then we need the integer, two integers, x and y. So, since this is a variable, what we could do is just something simple, right? Const value, and what we could do is assign this right here, okay? Maybe this is a bit more, intuitive, okay? So since func is just a variable, but it's a function pointer, it contains a function pointer, so it returns value, okay? Because it's returning an integer, whether that's from the add function or the sub function. So we can capture that return value, whether it's from add or sub, and place that in this variable and just print that variable. This is the same thing. It's the same exact program. We're just capturing the return value of func, which is a variable, but it contains a function pointer, and now we're printing that. So now let's run this. And I'll say add, and we'll do 55 and 77. And you see it runs just fine, 132. So that's the same exact thing. And again, this is the function, and here's the function pointer. And again, this is the same thing as saying, right? It's the same thing as saying that, or that right there. So now let's look at, so let me show you an example of what it would look like in order to, say for example, put a function pointer as an argument to a function. So so we'll say name, and we'll return a string, and we'll just return my name. Okay, so this is just a function that returns a string. And now let's call greet. And what this is, so this can be named whatever you want. Let's name it func to keep it consistent with our other example. Okay, now it's a function pointer. Okay, it takes no arguments, right? This is what we're going off of. We're going off of this signature here. Okay, and it returns a string. Okay, and we're going to, this function is going to return void. Okay, and what we're going to do with this function is just print the string that we pass in. Okay, so now let's call it a, and assign a function pointer to name. And so now, okay, let's call greet and pass in a. And when we run this, it's just going to print my name. Oh, it's actually this right here. And you see it just prints my name. So let's look at that again. So you see, this is what the right, this is what it was trying to highlight. This is why it wanted to spell this out for us so that we can see the way that these function pointer types are written. And so that's what this is here, this parameter. This is it right here, okay? It's a function to, it's a pointer to a function that takes no arguments and returns a string. Okay, that's what this parameter is, and it's named func. Okay, and again, when you call a variable that has been assigned a function pointer, you call it just like a function. So let me move this over here. Okay, so you see what that looks like? It looks just like a regular function call. Okay, and then what you could do, what I'm doing here, is just assigning the function pointer to a variable, right? Just like we're doing here. Okay, that's all this is. This is the same thing. Okay, it's like saying const func equals function pointer to add. So you see that's all I'm doing here. And then I'm passing this in to greet. And it's being called here. Okay, so when this program runs, it's going to just print whatever string I have here. Now obviously this is just a trivial example. But hopefully it's enough so that you can see how these types are written and how you can actually define functions that can take function pointers. It's really just this simple. It's not that difficult. At least I apologize if it does seem that way. It might, and that's okay. Programming just takes time and effort, and I can assure you I am not the best programmer in the world, okay? And you know, the more mistakes you make, the better, perhaps, because that's the way you learn. You learn by making mistakes. You learn by experimenting with the language and understanding what you can do. Okay, but this is the way. This is the way that you would assign a function parameter to a pointer to a function as a parameter. Okay, so that's what this looks like. So I hope that was helpful. If you have any questions, let me know. Or again, where the best place to probably get help on this particular issue, because you'd have to like show your program or something like that, would probably be the Hare user mailing list. But I would be more than happy to try and help you in the comments. So um, that is just fine. So that is function pointers. Let's go ahead and move on to the next example. Okay, for this next section, this is the init, fini, and test attributes. That's what these are. They're often called decorators, like in Python. and it's fine to call these decorators. In fact, I think the tutorial does, but their technical name is an attribute. Okay, like if you look in the spec, that's what these are called. They're called attributes. So we have already seen some function attributes throughout this tutorial. We'd like to explain the ones you've already seen and introduce two more, init and fini. Decorating a function with init causes it to be run when your program starts and is useful for initializing your application state. Fini is run when your program is terminated, which is useful for the opposite. In this sample, we use it to prepare the global src variable with the program's own source code. You've already seen test, so this is a test attribute. This marks a function as a test function, which is only used when you run Hare test. There are a few other attributes supported by Hare, but they're generally only useful in specific, uncommon situations. You'll know if you need it. Okay, so let's step through this. Let me jump over here. And so we just have a global variable. I've moved it up above the main function. That's the only change I've made to this program, just so that we can kind of get a little separation of logic, and you can understand that this is a global declaration. Okay, and it's just an empty string. And so init is run before the main function. So this is going to run, okay, and then the main function is going to run, and then this fini function is going to run after the main function. So it kind of cleans up the state and does cleanup. And you see it's freeing. It's calling the free keyword in order to free what's allocated here, src. So what we're doing is the init function first runs before main, and we're opening the file, okay, deferring IO close, and then we're draining the file. IO drain, it just reads it into a slice of bytes, and then we are taking those slice of bytes, transforming it into a UTF-8 encoded string, and putting it in the variable called source. Now IO write is just writing this to standard out, takes a handle in a byte stream, or a byte slice, and so because it takes a byte slice, okay, um, we're calling strings to UTF-8 and converting it into a byte slice. So okay, so you see we're converting it to a byte slice because that's what IO write expects, okay? And so this is just writing this to standard out. Here's our handle, it's OS standard out. Okay, this is unbuffered, I believe. Okay, buffered, sorry. There is another version of standard out that is unbuffered. So OS standard out is standard output that's buffered. And then what we're doing once this runs, okay, so we're writing our program. What we're doing is we're writing our program, main.ha. Now if you don't have a main program, this isn't going to work. You have to have main.ha, okay, in your current working directory in order for this program to work. If you don't have a main.ha, this is not going to work. And then we are writing it standard out and then freeing this resource. And again, that's what these attributes are trying to show. So let's go ahead and run this. And you can see it literally just prints the source code of the main file. That's all it's doing here. It's printing the source code. Okay. Now, areas where you can actually probably use these are maybe say like a game. So if we go what did I do? So and I search for, you see there's bindings for SDL3, SDL2 and SDL3. So So where you might actually use these init and fini functions are like, say you're making a game, right? You would initialize like some initial game state, and then you'd run your game loop, and then say you want to exit out of your game, you do some cleanup to make sure that you save the game and right, do clean up all the state. So that's one area where you could use the init and fini functions. Um, since Hare is um, a low-level language designed for writing things like compilers, writing things like operating systems. I would imagine you could also write a loader for it too, right? When a loader loads a program, right, into memory to get executed, these functions, these are actually run, if we look at like some assembly output, um, these are actually run um, before and after the main function, right? When your program loads into memory to run, the main function isn't actually the first function that's being run. So I would imagine these are necessary, right? If you're writing an operating system in order to, when programs get linked and loaded, these are probably necessary for that. So that would also be another legitimate use case for init and fini, the attributes. So, but as a beginner or someone writing, most programs, you're probably not going to need these. I'm trying to remember. I'm trying to remember where I've actually seen these in the wild, like in an actual Hare code base. I might have. In fact, I'm pretty sure maybe I have, but outside of maybe something like Ares OS, right, or like an operating system, you're probably not really going to need these. Okay. Um, for your average piece of software, you're not going to need attributes. Okay. Um, so that's it on functions. You can see the next section is on modules, and I will try and get that video out soon. And that should be the last video. Okay, so that's it for the section on functions. I really appreciate you watching. Please let me know if you have any questions. Please put them in the comments below, and I will try my very best to help you. Or again, if you would feel more comfortable going to the IRC chat or maybe the Hare user mailing list. So that's it for this video, and until next time, thank you so much for watching, and have a nice day.